think about that for a title. A piece of calculated confusion and some Power Stroke diesel stuff. A lot of people are really interested in the Power Stroke diesel stuff, and I'm just going to give you a little bit of an overview and ask a few thought-provoking questions about some of the choices that have been made, and so on and so forth. And I'll tell you a little bit about what I know about some of the diesels, and I've got some experience with those. One of the things that I was want to start out with, though, was something different. This was something that I always thought was very interesting on these late 90s Toyota 2.2s. You see that little situation right there where you've got on this cap right here, there's a couple of marks. Now that one, I got that marked in white, and then there's this one up here. Now the ones of you guys that are familiar with those engines are already thinking about this, and somebody may have the answer to this. I haven't really researched it, but you might notice that this is the wrong mark to use whenever you're lining up the timing gear, the cam gear. This is the right mark. It's supposed to be here, not there. Well, my question is, what's that mark doing there? Now there may be, and this is not an interference engine, so it's not a place where you would set the camshaft so you wouldn't bend valves. And so what I would say, if some of you people that are really sharp on Toyotas knows what this other mark is for over here, I would really like to know. Because, why would it be there where it so perfectly lines up with that hole if you weren't supposed to use it for anything? I could be just totally off base here, even wondering about that. But I do remember we're doing some work on an 87 Camry, and there was a Toyota mechanic that told me to line that up with that hole to set the timing, but then I realized later that this one here was the one I should have used. Okay, now the 6-liter Power Stroke, I had a bunch of material out there on the 7.3 Power Stroke, and a lot of you guys kind of have some knowledge of the 7.3, which had those hydraulic electronic unit injectors, they called them. And those HUE injectors were made by Caterpillar, and they basically they had an intensifier piston in there, and they had a solenoid on the top with just a couple of ohms of resistance, and they used 115 volts, and they would let this high oil pressure there was a control. The engine controller was able to control the oil pressure that was allowed to enter these injectors, and as it energized the solenoid, it would allow that oil pressure to act on top of that intensifier piston, which was 7 times bigger on the top than it was on the bottom. And whenever the fuel was, like if you had, let's say you had 600 pounds of pressure coming in on the top, then you multiply that times 7, which would be 4,200 pounds on the bottom of that, and the thing could go up to 3,700 pounds of high oil pressure. And if you multiply that times 7, you can see that the amount of fuel pressure that was applied to pop those injectors and to allow them to squirt, spray that real fine fuel in there on the 7.3 direct injection diesels was really a very interesting way to handle that, and it was pretty doggone reliable too. I replaced a pile of those injectors. I worked on those engines for about 6 years. This 6-liter though, it came out with a slightly different setup on the fuel injectors, and I'm going to talk about that in just a minute, in 03, and I was introduced to that when I went to the Power Stroke Rally up there that one year. Well, the first time I went to a Power Stroke Rally, actually, while they were still building the 7.3-liter Power Stroke engine at the assembly plant when I went, but they were getting ready to start building the 6-liter engine. Okay, so this throttle plate on the early 6-liter engines was there for the purpose of changing the pressure. So if you start to close the throttle plate a little, it enables the pressure to drop. It drops the pressure a little bit in the intake manifold and allows EGR gas, when the EGR valve was open, which they started being concerned about oxides of nitrogen on diesels, right along in there, and they were reducing the amount that you would be able to, that an engine would be able to legally produce as far as EPA goes. All right, so if you close that throttle plate part of the way, you're not regulating the power of the engine on that thing. Although if it's stuck shut, it obviously would, but didn't typically have a lot of trouble with it. That was supposed to make the EGR work. It let the EGR freely flow in there because it would lower the pressure in the manifold enough so EGR could flow. And so that's the reason that throttle plate was on that 6-liter. I thought that was very interesting when I first saw that. This is how it was kind of wired up. In a way, it's simpler than the throttle bodies that were on the that are on the electronic throttle bodies now, with all the redundant potentiometers and all this kind of stuff. This one here didn't really have the capability to let the vehicle run away. If it malfunctioned and stuck closed, it would basically choke the engine down so that it wouldn't run. So they weren't too terribly concerned about having everything so redundantly connected to this throttle body because of the nature of the job it was supposed to do. You might notice it was very simple here. It just had a couple of wires going in there where it would drive it back and forth via these gears. Of course, there's your EGR valve right over there close by it and all that. But the newer throttle bodies, and I'm always speaking warnings about those, is on the newer throttle bodies with electronic throttle body vehicles, keep your hand out of the throttle body, keep your finger out, because if somebody is holding that gas open, or if you push it open with your finger and the engine's not running even, it can just destroy the throttle body on some vehicles so that you wind up having to buy a throttle body. So the best thing to do is switch on the key, have somebody push the gas pedal to the floor inside the car, and it'll open the throttle plate all the way up, and you can clean it with your toothbrush if you feel like you need to or whatever. But if you happen to get your finger in there and your buddy takes his foot off, the spring tension is not what closes that when the key is on. It actually drives that thing closed, and it's got enough power to cut your finger off. So keep your finger out of anything you don't want cut off. Needs to be kept out of that throttle body. And basically that's just a little bit of warning. But this one here basically did a different job, and so they didn't put redundant sensors all over the place on this. Even though the 7.3 had a redundant setup, it had a potentiometer and what they called an idle validation switch in there on the gas pedal. Sometimes we'd have to replace those gas pedals because of the fact there was it was an electronic throttling up as it did, because it would change pulse width and all that kind of stuff totally, and you could put cruise control on one of those fairly easily too if you knew how to do it, because it was built into the engine controller on those 7.3s all the way back to like 95. Of course they came out in 94. But anyway, how did this make the throttle plate unnecessary on the 6-liter diesel? In 05, they used a scoop. They put a scoop in there so that when that exhaust was flowing through there, it would come up to that scoop and it would go into there, and there was a positive pressure on that EGR, and it enabled the exhaust gas recirculation to work without needing a throttle plate. And that removed some hardware and obviously reduced the cost, the number of circuits. There was a bunch of different goodies that came about on the EGR system from them putting a scoop inside there. And it just made all the sense in the world when you think about it. Now on these cutaway engines that I'm going to be showing you little bits and pieces of, white is intake air, red is exhaust, and then purple will be high fuel pressure and high oil pressure if they're on the ones that have the high oil pressure like this 6-liter driving the injectors, and then pink will be fuel. All right, but why did the 6.4-liter Power Stroke diesel have this throttle plate if they had already got past the need for having the pressure differential for EGR? Well, this one here, the reason that one's there is to help with diesel particulate filter regeneration, which is kind of like a self-cleaning oven. If you heat that soot up hot enough, it just turns into a fine ash and goes out of there. That particulate ash that it's handling. And so what it would do is it would put a little more fuel in there while cutting the air down, and it would make that converter that particulate filter get super, super hot. So it was, like I say, like cleaning your oven. The carbon that's on the inside of your oven, when you do the oven cleaning, it goes up like 800 degrees or something like that. And it just turns everything in there in the way of carbon into ash. And it's like a really nice clean oven. Some of us would, back in the day, would like to if you ever saw a engine that was leaking water, people were just putting straight water in there because it was moving through there so fast, and it was going through one of the cylinders. And when you'd pull that cylinder head off, that cylinder that was getting water would have a piston that was super, super shiny and looked brand new. So you can actually, pour in some water in there is what people used to do on some of them to clean the carbon off the pistons. Before there were catalytic converters, some of the older mechanics would pour, believe it or not, they'd pour rice down there. And that old dry rice, when it went through there, it would clean that carbon off, and it would come out the back of the tailpipe of the car, look like Rice Krispies, Anyway, this had nothing to do with EGR operation, but on the 6.7 liter diesel that was made by Ford, they returned to the throttle plate to facilitate EGR flow, which this was what was going on back on the 6 liter that was created by Navistar. This is a Ford engine, the other one was International, Navistar, International. And so that was what this one here was for. And so I thought that was very interesting that they went away from the throttle plate because they figured out a way that they could do it without it, with no moving parts, just using physics. Then they had to put a throttle plate on for catalyst reduction. I expect, if the truth was known, the literature that I had didn't talk about it, but I expect they probably use this for catalyst reduction too, by cutting some of the air off the same way they did on the 6.4. It didn't mention that in the documentation I had that I was using to build this. This was a 6 liter Power Stroke diesel, the 03 model, and this pipe has got a different configuration on the later model. It's more flat than that. But anyhow, I took this photo at the assembly plant. This is the high pressure oil pump. Doesn't require any kind of timing or anything because it's just jacking up the oil pressure that's going to be used for the injectors. You also might notice that these gears right here are in the back of the engine rather than the front. And it was pretty ingenious the way they had it designed. This front chamber up here had the oil cooler in it, and then back here, there was this little chamber that had the oil pump. And so that's kind of the way that went. This pumped that oil up into that oil rail. And that oil rail, it was a kind of a common rail, but it was for the oil. And then the fuel was fed in through the cylinder head of the injectors. And we're going to look at that a little bit closer here in a minute, how the injectors work. There was a 60 -2 tooth crank wheel on this 6 liter. And the 2 missing teeth. We're used to having a 36 -1 on the gas burners. This was a 60 -2. Interestingly enough, the Duramax engines use a 60 -3, which I think is pretty interesting. That's how that worked around, and this is a crank sensor. Now you might remember on the 7.3 there was no crank sensor, there was only a cam sensor. Alright, this is a 6.4 liter Power Stroke, and this is a 6.7 liter Power Stroke. Now that one there is not a cutaway engine, but you can kind of see what's going on there. Just a neat little graphic that I put up there so you can see both those engines. Alright, now the 6 liter turbocharger was variable geometry, and what that meant was it moved these vanes because whenever the engine was cold, it didn't need a large turbocharger, particularly they just needed a small one. And they also wanted more back pressure for heating up the cabin. You might remember on the 7.3 the turbocharger back there had a little valve that closed up that choked the exhaust gas down some coming, so that they wanted to warm the cabin up faster. That seemed to be a big deal that they were concerned about. What they used here was a little rack and pinion assembly. This was driven by oil pressure. Now on these other, I'm also going to tell you that pressurized lube oil is actually pictured in orange whenever you're looking at these cutaways. There's exhaust, see? Over there on this other side, this right here is where the exhaust would spin that impeller, and on the other side that turbine. And so basically this right here would go back and forth, and it moved a little shaft that was hooked in a hole. I'll show you a little bit closer how that works in a minute. And there was a rack and pinion set up operating this thing, and I had that one in my hand right there that I was holding. That solenoid is, mounted right there on the turbocharger. And so the variable geometry turbocharger worked really good. Interestingly enough, Cummins, and also this turbocharger here, the Duramax, is exactly the same principle as this. Now, as I remember, there are some parts of the Duramax turbocharger that are stainless steel, you know, in these vintage vehicles and all that. But it's exactly the same turbocharger, and this turbocharger, as I remember, was made by Garrett. But anyhow, that an interesting little setup right there. Now, what it did, you might notice, to see this little round, this right here, as it turned that back and forth, it's got a slotted hole. It would basically move to open and close those vanes, right? So when the turbocharger vanes are closed, the engine's got higher exhaust back pressure, creates more heat, and allows the engine to reach its normal operating temperature faster. And you know, this is on the exhaust side of this thing. Furthermore, when that exhaust is forced to go through those little small things, it spins the doggone wheel faster, and it makes this thing act like a small turbocharger. I remember one time I worked on a Ford Escort. It was probably the only turbocharged Escort I had ever seen in my whole career of working on those. It was a brand new car, and whenever the boost kicked in, there would be a little green light on the dash. It'd come on. It wouldn't have a gauge for pounds. It would just boost. And when I opened the hood and was looking, this was factory now. It wasn't somebody put on there. The little turbocharger was a little bitty thing. It didn't look a little bigger than a pancake. I thought, oh, that's a joke. I wonder what they put that on there for. Well, I had to do some kind of work on the car, I don't remember what it was, but when I went out to drive it, and I just took off on it the way I ordinarily would on an Escort going into traffic out there on that heavy traffic, when that turbocharger kicked in, that son of a gun broke the tires loose, and torque steering there about jerked me into the ditch. It scared the daylights out of me. That thing would just scoot when that little green light popped on. We started getting boost. Now this right here is a 6.4 liter turbocharger. You might notice this one is going through, this is actually pumping air through that one, as I remember. I forget that. I've slept since the last time I drew a diagram of that. But I actually was there at the rally, and I did this. So you can see what those vanes are doing. See, these vanes are slightly different on the newer one than that. And this assembly here is basically operated on the CAN bus. But this is a smart assembly. Whenever the engine controller, most of the time, because of the fact that they've got the circuits in the engine controller so crowded they don't have room to put transmission control circuits in there, they don't call it a PCM anymore. They call it an ECM, because all it does is control the engine. And they'll have a separate controller for the transmission on just about all these vehicles nowadays. So we went from General Motors calling their engine controller an ECM to the term PCM, which was J1930 regulation terminology, powertrain control module, because it was controlling the engine and the transmission. And we went from there back to ECM because things got so complicated they didn't have room in the engine controller to stuff all those circuits and logic chips in there and all that kind of thing, control everything. But this thing right here is basically got a cooling line that's hooked to it with a separate coolant supply and pump and all that. That basically, and that's the cooler over there. You can barely see it, but this thing right here. Well, what will happen? Let's say that this box and that one are the same thing. I guess it's two different, obviously. If this received a command from the engine controller to do something with the turbo vanes, and this thing was running too hot, because you notice it was really close to this, then it would refuse to do anything with the turbocharger until the engine controller turned on the pump to pump some coolant through there to cool it down. So it could actually refuse a request of the engine controller under certain conditions, because it's a CAN bus. The only thing that, in the early days, the only thing that CAN bus did was it was a communication between this turbocharger controller, then it just had a piece of linkage and it moved those vanes, all it did, and the engine controller. So it could refuse a command, that's the point. Alright, the 6.7 liter turbocharger uses a dual boost turbocharger with one exhaust turbine, 2 intake compressors, and this one uses a wastegate. Even so, the exhaust turbine has variable vanes that change with engine oil pressure from a PCM controlled solenoid. So this one here is sort of like it's like a dual charger. which is a pretty interesting setup, you know, if you think about it and all. And you can see those vanes right over there. All right. The fuel system differences with 6-liter uses oil control with 2 solenoids. These 2 solenoids are right here. And they basically have a spool valve in between them. And they basically will pull that thing back and forth. And it's fed by low pressure. All right, let me do this. See, your opening coil and your closing coil moves that spool valve back and forth so that it can determine how much pressure goes down to the top of this intensifier piston to drive down here. And whenever the fuel pressure gets enough, it will actually cause that little needle to lift off of its seat against that spring, and it takes many thousands of pounds for it to do that. But it's multiplying this by a factor of 7. Whatever pressure's coming in here is going to be multiplied by a factor of 7 down here. It takes 48 volts at 20 amps to operate the opening and closing coils on these 6-liter injectors. Now, I also thought it was interesting, the earlier Power Strokes took 115 volts to operate their HUE injectors. These injectors, incidentally, were made by Siemens, a German company. They got away from the Caterpillar injectors, and it kind of ticked Caterpillar off a little bit. But the Delco injectors, or whatever it was on the General Motors Duramax, which basically it looked like a Suzu and Bosch and all that came together to make that one. That was 93 volts. And another interesting thing about these right here, now that was Common Rail, the Duramax one was. Now the crazy thing about the Duramax was it did not have a pump in the tank feeding the fuel to the high pressure pump. It basically depended, this is a Bosch thing, it depended on the high pressure pump to create 10 inches of vacuum or something to draw the fuel out of the tank. Anyway, and so you might see a little coil there where that was cut away. I took this picture myself at the Power Stroke Rally. They had a cutaway engine so you can see how all this stuff works. Pretty darn cool. And so I don't know if you got any more questions about that or not, but or if I forgot to say something. Oh, by the way, to start with, they had this thing where it would pulse the fuel in there, you know, jitter that thing back and forth to pulse the fuel in there for a smoother idle and better fuel economy. But they wound up with some idle surging going on because of that, and there were enough customers complaining about it. You know, customers are good at doing this to themselves. That Ford sent out a reflash for the engine controller to do away, you know, with this thing, you know, bouncing back and forth and putting the fuel in there with a, you know, pulsation, if you want to call it. I'm just giving you this in the way that I describe it. Anyway, I do know for a fact that after they reflashed these, the fuel economy on these 6-liters went from like 18, 19 miles per gallon down to 13. It was not a good idea. And you couldn't go back the other way. If you were grousing about your fuel economy, that was on you. Right? So, I mean, after they did that reflash, now if you refuse the reflash and put up a little bit of a rolling idle, you were better off on your fuel economy. But it's almost like they were smacking you down. I don't think they did that on purpose. But the fact that they wouldn't go backwards with that was pretty interesting to me. So, anyway, there was, when these things first came out, you know, this one guy over at the Ford dealership said if you were driving one of the the ones that didn't have dual wheels on it, you could get going 20 miles an hour on one of these with a 6-liter in it. And a lot of people are driving 6-liters now, and they may say, oh man, we'll do that. But some of those new ones, when they were running empty and they were brand new and crisp and all that, if you got on it really, really hard, they would start the rear wheels spinning, and they would keep them spinning until it got dangerous, you know. And that was something that one of the diesel guys told me over there. I never experienced that, but that's what he said, so take that with a grain of salt. Now this right here is a little closer look at that. This is a rundown. You got a piston return spring, valve opening pressure spring, you know, where it popped the injector. And there was a fuel strainer where the fuel went in from the side through the head, right? Piston return spring, intensifier piston. You can see that's kind of shaped like a nail. See, it's a lot bigger up on the top than it is on the bottom. If you know anything about Pascal's law, you'll know that when you put pressure in here, it's going to multiply it by a factor of 7 based on the difference between this and that. And there's your spool valve opening coil. And that's, you know, Pingus fuel pressure. See how it's coming in through the head, through that little passage there, into the injector. And the oil is fed in through that big oil rail that's on the top. And so there you go on that. Now, The 6.4 and the 6.7 are called common rail systems, which that's really kind of a misnomer because all multi-point fuel injection systems are basically common rail because the same pressure rail is feeding all the injectors. Now, gasoline direct injection is, you know, some people call that common rail, but as far as the main difference on that is the GDI is putting the fuel directly into the cylinder instead of putting it behind the valve. But anytime you've got a bunch of injectors that are being fed out of one rail, that's a common rail system regardless of which way you talk about it. The reason they call diesels common rails, and it became an issue, was their injector pumps on the older diesels had a separate high pressure line going to each injector. And furthermore, that line had to be a certain length. It couldn't have more than a certain radius of bend in each line. So all of the lines had to be exactly the same length on those old, well, the ones that had the injector pump that had all the separate lines snake into each injector, and it would send these pulses of pressure to the injectors, and that would pop the injector, and that was, you give your injector timing to it that way. And that's because each injector had its own separate little line going to it. They didn't call that common rail. But common rail injection basically has a rail that's feeding all these injectors with the same amount of pressure all the time, and they're electrically operated. And you know, it's the same way on both sides. And this right here would be the pump that was going to be feeding that. Now, Dodge and Ford typically like to feed the high pressure fuel pump. Now, this is fuel, not oil. The high pressure oil on the Huey system and on the 6-liter was what gave the injectors their punch. This right here, this pressure right here, can be many, many thousands of pounds. I remember the numbers on the Duramax. If you disconnected the little pressure control solenoid, that thing would go to 23,550 pounds of pressure when it would default to high pressure. The Fords tended to default to low pressure, at least on the Power Strokes that I worked on, the old 7.3s. This one here's your fuel cooler. This is the one I showed you the picture of that had the dual turbocharger a while ago, that had the little animation of the vanes going. And so, you know, you got a filter here. A horizontal fuel conditioning module was an interesting critter. It's under there on the frame. It had a filter and a pump in it and a little water and fuel sensor down there. It looks like that in the real world, but there's also a little drain on it, a little yellow handle where you can flip this thing around and drain the fuel out of that if you decide you want to. And, you know, of course, then there's a little check ball right there, and so on and so forth. All right, so that is a 6.4. This is a 6.7. They're called common rail systems, not both of them are. And this is a 6.7. See the difference in that one and that one? All right, so look where that rail is right there, okay? All right, now look at this one here. This one right here, you got this rail. There's a fuel pressure control valve, okay? And this one here, there's a fuel volume control valve and a fuel pressure control valve. It's got one of each, right? Okay, now on your GDI engines, they basically have a sensor in the fuel rail that's telling it what the fuel rail pressure is as a feedback. This one here has got that too. Well, I mean the other one does. Okay, so let me go here, excuse me. Alright, so right there you got a fuel volume control valve on here. You got a fuel rail pressure sensor on this rail. And you got a fuel pressure control valve, which can actually be used to control the pressure. This one determines how much fuel is going in there out of this high pressure pump. This actually is a fine tuning pressure deal. You know, and so there's a little connection right here that they don't really show, and it feeds all of the injectors. So I guess you would call that, this is the common rail, and it's got, you know, lines that just basically are feeding it the same amount of pressure to every injector and all that. Of course, there's also a return, you know, that is used for this, is the way I understand it. Anyway, the 6.4 and the 6.7 injectors use piezo, and whenever this piezo actuator is not energized, it is about 1/1000th of an inch shorter than it is when it's energized. And that is just a tiny little bit, but it's enough, because whenever it energizes it, it basically stops up a vent and forces that fuel pressure to go up high and pop the injector and all that. So basically the fuel is bypassing through this little thing, this little stack of piezo crystals here is what makes that work. Now, Duramax injectors, the earlier ones, didn't use piezo the way I understood it. They were just electromagnetic, but I could have been wrong. Typically, this kind of injector, though, requires a heck of a lot more volts. Like usually, if I'm not mistaken, it's like 125 volts or something like that, maybe more than that on these. I was looking for voltage numbers on those, and I wanted something good and solid to give you, but I do know they use higher voltage than conventional injectors. And when the current's applied to the crystals expand, and when the PCM, excuse me, supplied current is removed, they contract. So when they contract, you're basically not injecting fuel. When they create voltage, though, and current, because current flow reverses. You know how piezo elements do that. They actually create voltage with pressure. Matter of fact, the heart of these little pulse sensors that you have is a piezo. You know the little pickup that you can get. And I'm going to show you that one of these days for a guitar that you put in there, and it basically makes your electric guitar put out sound and all that. You can actually put one of those in a closed chamber like a bottle or something and hook wires up to it to your scope, and you can make yourself a pulse sensor for almost no money, But anyway, this PCM supplies current to the piezo stack. When it's de-energized, it's removed. Alright, now I'm going the wrong way, sorry about that, got the finger on the wrong button. Stored by the PCM, this is interesting to me, it's stored by the PCM to actuate the injector on a companion cylinder. So basically when this one de-energizes, it's kind of like whenever your points, you remember how your points, whenever they would close, they would charge up that capacitor, which was the condenser in the distributor, and when the points opened, it would basically, when they opened, it would charge the capacitor because the spark that was trying to jump between the points would go into the capacitor. And then whenever they closed, that capacitor would discharge, and it would send all that voltage back in there to saturate the coil a little faster. That's one of the reasons if the condenser was bad, the spark wasn't as strong and all that. But anyway, they basically used that. This is a whole bunch of engines. I took that picture at the power. The first year I went to the plant, they actually let us walk around in there and take pictures, and it was just really a cool thing. They were so friendly at that Power Stroke Navistar engine plant. I went one time up there as a journalist, and I was the only journalist that they really invited. I was totally amazed at that. And this guy showed me around the plant. I didn't go with all of the other all the Power Stroke owners that were touring the plant. They says, you're going with this guy here, so I went with this guy all over the plant. He told me anything I wanted to know. He showed me a clean room where they would take on the 6.4s and they would put the heads in there and pressure up the fuel system with many thousands of pounds of pressure, and they had dye in the fuel they were pressuring up with, and they would have black lights in there and cameras and all to see if there was any leaks anywhere whatsoever. And that room had sensors in there so that if there was dust particles more than a certain concentration or a certain size, they would shut the room down and they would clear the air out of there with special filters and all. I thought that was very interesting. I mean, the room wasn't much bigger than this room I'm sitting in, but he pointed that out to me and explained it in detail. And then we went around there to this big Boehringer crank grinding machine where there was a big old guy with a hard hat on, some safety glasses, and there was a computer screen up there, and he was grinding a crankshaft in there. And you could see it in there through the windows in these big closed metal doors. You know, they always have everything so their filings are basically collected and washed away, and then they send them to the foundry and they turn the filings back into metal so they have almost no waste whatsoever. They're pretty good at that. But anyway, I was looking at that crankshaft. I was really interested in that, and I said, tell me about this machine here. This guy got the attention of the guy that was running that big Boehringer crank grinding machine, and the guy stopped the machine, opened the doors, and he released the crankshaft, and it dropped onto some little cradles in there, and he told me in detail how that thing worked. And I'm thinking, man, I don't know anybody that would stop production just to talk to some yo-yo like me. And so I asked the guy, I says, after you get through grinding this crankshaft, you know, who measures it, you know, just to make sure that it's right? He goes, nobody needs to. I thought that was interesting. But when they're assembling the engine, you know, like when you're building an engine, how as soon as you torque any of the caps, you always turn the thing to make sure that it hadn't picked up a lot of extra torque resistance, so you'll know that everything's all right. They actually do that in the plant too, although the machine is what turns and measures the turning torque on it as it's being assembled. And if anything goes out of line, they got to pull that engine out off the line and send it over and, you know, recheck everything. Didn't happen very much. Also, when I was going through the assembly plant, every single one of those engines, as I remember, let's see, wait a minute. It might have been every 100 engines they built, they started it up, or it might have been every 10. I don't remember all those numbers. I got them written down somewhere, but that was cool as all get out, how that went. All right. This was a bunch of 6-liter engines that they had built. They were ready to drop in vehicles. And you know, one of those engines right there, if you needed to buy one for your 6-liter truck, would be about $20,000. So that's a lot of money sitting there and all that. But today, we are done talking about the diesels. And if you like this stuff and you want a little bit more about the diesels, I expect I can probably give you some more in a later video. But just make comments and let me know. And I really appreciate you guys for watching. We'll talk to you next time.